let's start with a new chapter, which is surface area and volume. Just like we said about two-dimensional figures, or as we know about two-dimensional figures are any figures which could be drawn on a plane or which could be represented using a plane. For example, if I am taking a square, this is a two-dimensional figure. So, what do we have as, how do we explain the area enclosed by this? Then we use area of the figure, right? And then when we are talking about the boundaries, we have perimeter of the square, right? Now, when I am transforming this square into a three-dimensional object, this square becomes a cube. So, this square is transformed into a cube, which is a three-dimensional object and which needs three coordinates to explain what a cube is. So, basically, when we are talking about the cube, we have different things. Instead of area and perimeter, we talk about the surface area and volume of three-dimensional objects. So, what is surface area? So, when we take an object, so what is the area covered by the surface of it? Or let's say if I am taking this as an object, this is a cuboid, right? This is like rectangular faces, right? So, what is the surface of this, right? What is the area enclosed on the surface of this? It is called the surface area of a figure, right? Or shape. Now, what is volume? The volume is the capacity or amount of things which could be enclosed inside of that object, right? If we are taking a cuboid box, we know the cardboard boxes, right? So, if we are taking a rectangular box and we are putting some things in it, the amount of things which could be put inside the box actually explains what is the volume of the box, right? Now, let's move into details about like each and every figures or three-dimensional figures, and let's talk about their surface area and volumes in this chapter. Now, first of all, we are moving on to a cube. So, we know that the cube is a three-dimensional geometrical version of a square. So, square is basically a two-dimensional object, right? Now, when we are transforming it into a three-dimensional object, we get a cube. So, how do we find the surface area of the cube? So, how many faces does a cube have? So, if I am considering a cube, like this, right? So, this is a cube. Now, how many faces does a cube have? 1, 2, the one behind 4, 3 and 4 on this side. Now, on the top this would be the fifth face and on the bottom this would be the sixth face. So, what is a face? Face is actually, this is one face. This over here is actually one face of a cube. And what are the shape of the faces of a cube? It is a square, right? So, we have 6 square faces. So, what is the area of a square? Area of a square is equal to the side into side, or we could call it as a square, right? Now, how many faces do we have here in a cube? We have 6 square faces in a cube, right? So, we multiply this with 6 and we get 6a square. So, surface area of a cube is equal to 6 into a is side length, so a into a. Now, what is the volume of the cube, right? So, imagine a cube, right? Now, the cube would have a base, a height, right, and a width. So, basically the length, if I am taking this as length, this is breadth, and the inside thing, this as the depth or anything, we could say that all of the three are same, like the length and breadth and the width is same, right? So, how do we find the volume which can be enclosed inside a cube? We just multiplied the length into breadth into whatever the height of the figure is, that. So, here all of these three is actually equal to a or one side length. So, that is a into a becomes the volume of the cube, and this we get as a cube. So, the volume of the cube is actually equal to a cube. Now, let's talk about the next figure, which is a cuboid. Cuboid is actually a very commonly found figure, because in day-to-day life we find a lot of rectangular boxes around us, right? So, how do you actually calculate the surface area and volume of this. So first of all, surface area of a cuboid is like total area of its all sides. So when we are taking a cuboid, this would be a rectangle, right? So behind the back face would also be a rectangle and it would be connected by other faces. It also have 6 faces just like the cube, right? Now, how do we find the surface area? We find the area of this face, we find the area of this face, the face in behind, we find the area of this face and this face, and we add them all together to find the area of the total cuboid, right? Now, there are 2 pairs of side at the same size, right? So, this side and the side behind would be equal, right? The area of this side and this side would be equal, right? Now, this side and this side also be equal, and these are the 4 sets of the same side. And what about this and the bottom side? That would be a different rectangle, right? So, what do we do? To find the area of one longer side, you multiply the length and the height together. So, one longer side, we multiply length and height together, right? Length into breadth is area. To find the area of the shorter side, you multiply the width and the height together. To find the shorter side, we multiply width and height. So, this is length and this is height. Let's say this is length and this is height, right? Here this is width and this is height, right? Since these are 2 longer sides and 2 shorter sides, we can write the equation of the total surface area. Let's call it surface area SA, right? 2 into length into height. 2 times length into height plus 2 times width into height. So, we found the area of a cuboid to be 2 times length into height plus 2 times width into height. Now, let's move on to the volume of a cuboid. Now, volume of a cuboid is the amount of space it can hold inside, right? Just like we talked about a cube, what is the volume of a cuboid? The volume of a cuboid is the amount of space it can hold inside. It's like figuring out how much stuff you can fit into a box, right? Now, to find the volume, what do? We multiply length into width into height, right? Now, let's move on to the next shape, which is a cone. So, we all have seen cones, right? We all are very familiar with the ice cream cones. So, when we are talking about a cone like this, we have to remember that the base of the cone is actually a circle, right? The base is actually a circle and then it goes up to a point, right? Now, what is the surface area of a cone? How do we find the surface area of a cone? The surface area of a cone would be, this would be pi r square, this would be the surface area, right? Now, do we take pi r square completely? No, we take pi into r into this L is called the slanted height. What is slanted height? If we are taking a cone from the point vertex here to any point on the base, right? The straight line which is drawn from the vertex to any point on the circular base is called a slanted height, right? So, pi into r plus L. So, this becomes pi r square plus pi r L. What is this? Now, pi r square is the area of this base. Area of the base would be pi r square. Now, what is the area of this surface? You know, we have a circular base and we have a cone. Now, what is the area covered by the conical area, right? That would be pi into r into the slanted height. So, we add both of these together and we take pi r to be common and we get pi r into r plus L. Now, volume of the cone is said to be 1 by 3 into pi r square, which is the area of the circle, into height. So, 1/3 of pi r square h is called the volume of the cone. Now, let's talk about cylinders. So, we are very familiar with the shape of a cylinder, right? You know, for the very example, we have Pringles chips which have a perfectly cylindrical container, right? Now, how do we find the surface area of the container? To find the surface area, we need to add up the areas of 2 circular ends. So, this one we have it as a circular end and the other end would also be circular, right? This would be form a circle, right? Now, for finding the area, first we will find the area of this circular base, right? Then we will find the area of this circular end and we add this up, right? So area of this would be pi r square, right? Now this would also be pi r square, right? To get the total area of both ends, we multiplied the formula by 2. So this is basically 2 times pi r square, right? Now the curved surface area. What is the curved surface area? How do we see a cylinder? So basically we have a top circle and then we have a bottom circle, right? And then we have a surface which is actually curved around the two bases, right? So how do we find the curved surface area of this? The curved surface area of a cylinder can be unrolled and turned into a rectangle. So imagine we have a cylinder, we are cutting it and we are actually placing it on a paper, right? Now we get a rectangle. A rectangle is actually wrapped around in a conical way, a cylindrical way, right? Now, so we get a rectangle, right? The height of the rectangle is same as the height of the cylinder. So if this is a crooked line, a straight line rule. So the straight line is the height of the cylinder. So this is the height of the cylinder. So this height would be the height of the rectangle we pasted, right? And the length of the triangle is the circumference of one of the ends. So now the formula of the circumference of the circle is 2 into pi into r, right? Now the area of the curved surface can be used as area is equal to length into height, right? So this is circumference into height. This would be 2 pi r h. So the total surface area of a cylinder would be, we could take 2 pi r to be common, right? This would be r plus h, 2 pi r into r plus h, or we could write it as 2 pi r square plus 2 pi r h. That is written here, 2 pi r square plus 2 pi r h. Now let's talk about the volume of the cylinder. So the formula of the cylinder is, basically how do we find the volume? We find the base height, base area into height. It would be base area into height. The base area would be pi r square into height would be h. So pi r square h is the volume of the cylinder. Now have you noticed what is the volume of a cone? It's basically 1/3 of pi r square h. So what does it say from here? You know, the volume of a cone is 1/3 of the volume of the cylinder, right? That means that we could actually, if we are taking a cylinder like this with the same base area of a circle, say that this cylinder and this cone have the same base area and the same height, right? If they are of the same height and same base area, we could fit 3 cones like that into this cylinder. That's what is said here. So the volume of the cone is 1/3 of the volume of the cylinder. Now let's talk about sphere. So sphere is actually a very common shape which we find, right? We have balls in the shape of a sphere, right? Now surface area of a sphere. So what is the surface area of a square? So let's say that a sphere is constituted of 4 circles, like we just take the 4 circles and 4 axes, and we could say that the area of a sphere is 4 pi r square, and also the volume of the square is 4 by 3 pi r cube, right? So what is the volume of the sphere means? It means that the amount or capacity this shape could hold, the amount or capacity of volume or space which is held inside the shape is called the volume of the shape, right? Now this for a sphere is 4 by 3 pi r cube. Now let's talk about hemisphere. So we talked about sphere, it's completely, a ball like structure. And what if we cut the ball into 2 parts? We get 2 hemispheres, right? So if we cut a sphere into 2 parts, there would be an upper hemisphere and then there would be a lower hemisphere. So how do we find the surface area of a hemisphere? That is one of the hemispheres. So we know that a surface area of a sphere is 4 pi r square. So we divide it by 2 and we get 2 pi r square, right? Now what is the volume of this sphere? Volume of this hemisphere, right? Volume of sphere was 4 by 3 pi r cube. So volume of a sphere would be 4 by 3 pi r cube divided by 2. Divided by 2 means multiplied by 1 by 2. So this and this would be cancelled out. So we get 2 by 3 pi r cube as the answer, right? Now right circular hollow cylinder. So when we talked about the Pringles case, right, we were talking about a cylinder which is completely occupied inside. Now what if we make a hole through the cylinder? We get a figure like this, right? So how do we find the surface area of a right circular hollow cylinder? Surface area is like the total wrapping paper need to cover the entire outside of the vada pav with a hole, right? Very nice example. To find the surface area of a right circular hollow cylinder, you need to add up the areas of two parts. First one is the outer curved surface area, right? This is a long rectangle that can roll into a, just as we talk about the cylinder. That would be 2 pi r h, right? Now, inner curved surface area, now this creates another long rectangle you can roll into. So, inner curved surface area would be 2 pi r h. So, what is this? So, we have an inner surface here and we have an outer surface here, right? So, outer surface area would be 2 pi r h and the inner surface area would be 2 pi but a different radius h, right? That is the surface area of a right circular hollow cylinder. Now, volume of right circular hollow cylinder would be, we know that the volume of cylinder is pi r square h, right? Now, we have pi into h, but r square, instead of r square, we have r square minus small r square. Why? Because this is r square, if this is r and this is small letter r, we have to find what is this, right? That is basically r minus small r. So, we get that volume is equal to pi r square minus r square into h. Now, let us talk about a right circular cone. So, what is a right circular cone? So, basically, we just talked about a cone in general. Now, in an ice cream cone, the cone is actually empty. There is nothing inside that, right? So, it doesn't have a base as such too, right? So, how do we find the surface area of this cone? The surface area is the total area that covers the outside of the cone. To calculate the surface area of the cone, you need to know two things: the radius of the circular base and the slant height of the cone. We talked about what is slant height. Slant height is basically this height. Normal height is actually from the center to midpoint of the circle, right? Now, slant height is actually from the vertex to one of the points on the circle, which is a straight line, right? Now, we know what is radius and slant height is. Now, area of a cone, surface area of a cone would be, we talked about it, pi r square plus pi r l. So, this becomes pi r into r plus l, right? Now, let us talk about the volume of the circular cone. Volume of the circular cone would be 1 by 3 pi r square h, right? Now, let us talk about the polyhedrons. So, what are polyhedrons? Polyhedron is a three-dimensional shape that have flat surfaces which we call as faces, right? It also has edges which are the lines where the faces meet, and vertices which are the points where the edges come together. So, polyhedron is a three-dimensional figure, it have flat surfaces, like it could be a triangle, it could be a square, it could be a rectangle, it could be a pentagon, anything. It could be a flat surface, we call it a face, right? It also have edges which are the lines which the faces meet, like two faces would meet at an edge. Like in a polyhedron, we could actually have different shapes as different faces. Like in here, we have a square as this face and a triangle as this face, right? So, how do we find the surface area of the polyhedron? We actually first identify all the faces. We actually identify how many faces are there for the polyhedron, and we see which are all the faces there, like triangle, rectangle, sphere, not sphere, circle or anything, right? Now, next calculate the area of each face using its length and width. For a square face, you can find the area by multiplying the length of one side by the length of the other side. So, basically, how do you find the area of a polyhedron? So, basically, you will find the area of each faces of a polyhedron, and then you add up all these area to find the total surface area of a polyhedron. Now, volume of a polyhedron, how do we find out the volume of the polyhedron? First of all, we actually identify what shape it is, right? And then we find the length of one side of the shape, right? And then multiply the length of one side by itself to get the volume of the polyhedron, right? Polyhedron we can't actually form a generalized formula. Why? Because polyhedron could be made of different shapes, right? I could add like 3 triangles right, together and say that it's a polyhedron. But what is it? It is actually a triangular prism too, right? Now, we have a very important but very cool formula about Euler's formula. This is actually pronounced as Euler's. So, Euler's formula for polyhedron. So, Euler's formula is a very cool and important discovery made by a mathematician named Leonhard Euler. It helps us understand the relationship between the number of vertices, edges and faces of a special kind of 3D shape called a polyhedron. So, a polyhedron means it could be anything. It could be a cube, it could be a cuboid or anything. So, what did Euler do? Euler actually made a formula which tells us about the relationship between the vertex, the edges and the faces of a 3D shape, right? So, Euler's formula says that if you know how many vertices, edges and faces of a polyhedron has, they are connected in a special way. The formula is V minus E plus F is equal to 2. So, what is V here? V is the number of vertices, E is the number of edges and F is the number of faces a polyhedron have. So, we got different polyhedrons here. So, we will see what all are the polyhedrons and however Euler's formula is applied to it. So, Euler's formula for a cube. So, we know that, let's consider a cube. Considering a cube, right? So, how many face, what is the Euler's formula? Euler's formula was number of vertex plus edges, vertex minus edges plus F, right? So, vertex minus edges plus the faces is equal to 2, right? Now, what is vertex minus edge here? Vertex minus edge. Number of vertex in a cube is 1, 2, 3, 4, 5, 6, 7 and 8. So, a cube have 8 edges, 8 vertices. Now, how many edges does it have? It have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 edges and how many faces does it have? It have 6 faces, right? Now, what is 8 plus 6? 8 plus 6 is 14 and what is 14 minus 12? It is equal to 2. So, we got the connection in the formula. This is the Euler's connection. We take any cube, right? Any type of cube, their corners, edges and faces would have this relation, right? Now, let's talk about a cuboid now. So, in case of a cuboid, if we have a cuboid like this, right, how many vertex does it have? Just like we talked about, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 vertex. Now, how many faces does it have? We have 1, 2, 3, 4, 5, 6 faces. And how many edges does it have? Just like the square, we have 12 edges, right? Now, we do the calculation and we again get by using this formula, we get 2 as the answer. So, again, Euler's formula is actually valid for a cuboid. Now, let's talk about Euler's formula for a pyramid with a square base. So, what is a pyramid with a square base? Pyramids are anything where we have a geometrical shape in the bottom and we have a point on the top. This point is called the vertex. Now, when we connect the vertex to every single point, every other corner, we get a pyramid, right? So, how many vertex does a pyramid have? A pyramid will have 5 vertex, right? Now, how many edges are going to have? We have 1, 2, 3, 4, 5, 6, 7 and 8. We have 8 edges, right? Now, how many faces do we have? We have 1, 2, 3, 4 and the face below we have 5. Now, what was the Euler's equation? We had vertices minus edges plus face is equal to 2. Now, how many vertex do we have? 5. How many edges do we have? 8. And how many faces do we have? 5, right? This is equal to 5 minus 8 is minus 3 and minus 3 plus 5 is equal to 2, right? Again, we find out that Euler's formula for a pyramid with a square base is valid. Now, let's move on to the next shape we are talking about. We have a triangular pyramid or a tetrahedron. right? For a triangular pyramid, the case is we have a triangular base, a top, so everything is connected to this triangle, right? So this is a triangular pyramid. So how many faces does a triangular pyramid have? We have 4 faces, 1, 2, 3 and 4. And for a tetrahedron too, we have 4 faces. Now number face is equal to 4. Number of vertices we have 1, 2, 3, 4 and that is it, right? For both tetrahedron and a triangular pyramid, we have 4 vertices. Now edges, these are straight lines connecting the vertices. In triangular pyramid, we have 6 edges and tetrahedron also have 6 edges. So let's check the Euler's formula for tetrahedron and triangular pyramids. So we have V plus F minus E. So V is 4 plus F is 4 minus 6, 8 minus 6 is 2. Again we got that the Euler's formula is valid for both triangular pyramid and a tetrahedron. So let's move on to the next thing, which is a rectangular prism, right? So what is a prism? Prism is basically something, we have, see, we have actually seen like a kaleidoscope or something, right? So prism is basically this, right? Now number of corners we have 1, 2, 3, 4, 5, 6, 7, 8, right? So we have 8 number of corners, 1, 2, 3, 4 and 5, 6, 7, 8. Number of faces, the faces are flat side, so we have 1, 2, 3, 4, 5 and 6. So we have 6 faces, and number of edges we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. So we have vertex, face and edge here. Now what is our formula? We have V plus F minus E is equal to 2. Let's check whether this is true for a rectangular prism. We have 8 plus 6 minus 12, right? So 8 plus 6 is 14, 14 minus 12 is 2. So this is actually true for a rectangular prism too. So what do we talk about in this chapter? In this chapter, we discussed about how to find the volume and surface area of different 3D figures, including cube, cuboid, then cone. We talked about cylinders, we talked about spheres, we talked about hemispheres, and we found out the surface area and volume for right circular hollow cylinder. Then we found out the surface area and volume for right circular cone, and then we talked about polyhedrons, and then we came into a formula which is a very interesting formula called the Euler's formula for polyhedron. We actually proved that how it is proved on cuboids and for a square pyramid, and then a triangular pyramid or a tetrahedron, and then we talked about Euler's formula for rectangular prism. Now this is all about the chapter surface area and volume.